Hello everyone. My name is Boya and I'm from the Security and Privacy Engineering Lab at EPFL. Today I'm going to talk about our previous work on privacy preserving humanitarian aid distribution. This is a joint work with my previous colleague, Walter and Justina Swenson. They are from the Red Cross and I'm supervised by Camila Chancoso. So humanitarian organizations distribute aid physically to people who are most in need of help. And traditionally, the aid distribution is based on a paper system. As you can see on the right-hand side of the slide, there are the ICRC staff, the Red Cross staff, who are checking the paper list at the distribution station. And the problem is that this method, this kind of paper-based method, does not scale very well to even medium-sized distribution. For example, the ones that involve thousands of households. On the one hand, this is an efficiency issue because at the distribution, it's just very slow to find the one correct row for a specific household among thousands, probably. And this efficiency problem potentially brings other problems like safety issues, because as we have seen that a lot of aid distributions actually happen in conflict areas where it is actually not safe for a lot of aid recipients and also the staff to be exposed in an open area for a long time. So with the need to improve scalability, the humanitarian organizations are searching for digital solutions. And this is why the ICRC, the Red Cross, came to us. My colleagues organized 2 workshops with the field experts from the ICRC Economic Security Program to actually learn the problem. And we also maintain these conversations throughout the project with the Data Protection Office. So from this year-long conversation, we would like to understand this specific scenario, the humanitarian aid distribution, because we don't want to design anything that could be useless to them, and we would like our design to align with the structure and the functionality of their aid distribution program from the start. So how does the aid distribution work? I will walk you through an example. The aid distribution program can be abstracted into roughly 3 phases. And the first phase is the registration phase. The aid we learned from what we learned from the ICRC, the aid is allocated per household. So there will be a representative of the household who will show up at the registration station. And the registration station will evaluate the need of people to decide whether this household is entitled to get aid. And for example, here in this case, it allocates 3 bags of rice and 1 baby formula to this household. And the registration station will write down this entitlement information on the paper list. So after the registration, the registered recipients can actually go to the distribution station to request aid, and we call it the distribution phase. The distribution station will check the legitimacy using the list from the registration station and to get the entitlement information. And after the check, another issue the distribution station needs to pay attention is the behavior we called double dipping. Because the distribution station needs to make sure this household has not already collected aid, that is no double dipping, because they want to prevent people from getting more aid than they're entitled to. And usually, the station will ask the recipient to sign their name as a proof of delivery. One additional thing we learned is that distribution can happen periodically, which means that a solution, either digital or paper-based, must enable periodical distribution without the need of registration every single time. So after the distribution, there is an extra step called the auditing phase. And this is because the organization wants to make sure the limited resources actually go to the people in need, and they would like to conduct internal or external auditing to provide this accountability, this transparency of aid distribution. What they usually do is to give the list with signatures to the auditor. Then the auditor can cross-check with the warehouse to see whether the numbers check out. So now we have seen the whole process of the aid distribution, and we know that what are the functionalities that a digital solution must preserve. And we also noticed that the bottleneck of this scalability problem is actually the checking of the name list. Just manually finding the name, asking for a signature on the correct row, all of these are very slow. So how about we just digitalize this list and remove this bottleneck of scalability? Well, a very intuitive and straightforward way is, of course, to set up a central database. We put all the data into this database, and we use the strong authentication, for example, the biometrics, to check legitimacy and to prevent double dipping. This is indeed more scalable, but it brings the privacy risks. For example, even a third-party auditor will know all the detailed, personal, and probably very sensitive information about the recipients. In addition, if we look closer at this approach, it's essentially a digital identity management system. So anyone with this database is able to link recipients' identity with their behavior, and holding this database can even create tensions between the humanitarian organization and the local authorities. For example, as this news shows, the World Food Program clashed with the local authority in Yemen on the control of such a database full of biometrics. So if we put the privacy issues into the humanitarian context, we see that actually the lack of privacy can first put recipients at high risk, and second, put the organizations in a very difficult position. So the question here is how to design a digital aid distribution system without these issues. So there are three main ideas in our design. The first one is to avoid a centralized database with sensitive information. We decentralize the legitimacy check into digital tokens. And the second idea is to prevent double dipping. We leverage the unforgeability of crypto schemes. And in the whole process, we try to minimize the data disclosure to provide strong privacy. And in this talk, we will focus on the privacy during the auditing. As for the choice of tokens, we choose smart cards and smartphones because from the conversation with the Red Cross, both can be practical in different areas. And the key difference between these two tokens with respect to security and privacy is that the card, in the card solution, we assume that the computation and the result are trustworthy, and the card is seen as a trusted execution environment. Well, we don't have that kind of assumption. We don't have the TEE assumption in the phone solution. And in this talk, we will focus on the card-based solution under the TEE assumption. So now let me explain how our design works. At the registration phase, we give the recipient a card. And after registration, the card stores the following information. It has a household secret representing this household, the entitlement information, a period counter, and any authentication information needed. At distribution, the legitimacy check happens inside the card. And if passed, the card outputs the entitlement to the distribution station so that the staff can hand over the aid. The recipient in this way proves their ownership to the token and hence the legitimacy of receiving the aid. Since the output of the card is reliable, a malicious recipient with, for example, a stolen card cannot pass the check. And second, to prevent double dipping, we let the card output a record that is unique per household per period. And we call this record a tag. The distribution station will send the current period, which is 5, to the card, and the card will use a PRF, a pseudorandom function, to compute a tag based on the household key, KH, and the period. This tag is then sent to the distribution station. The distribution station records all the tags that have been received, and if the tag is not seen in the past, if the tag is fresh, then the distribution station will record this tag and hand over the aid according to the output of the card. And in this way, a malicious recipient will not be able to double dip, because when they request for the second time in this period, the tag will match a record in the database. And the tags are pseudorandom. This makes sure a malicious distribution station cannot link the distribution behaviors across different periods. And therefore, we make sure to prevent double dipping without compromising the privacy. So for auditing, the idea is to let the card produce an auditing record that cannot be forged. And for this, we built in a global signing key, SK, into all the cards. The card will first compute a commitment on the entitlement. Then the card creates a signature on the tag, the commitment, and the period using this signing key SK. The distribution station will collect the outputs from the card and store these records. And later, when the auditing happens, we minimize the disclosure by sending only aggregated data without revealing the entitlement, for example, for each distribution, because the auditor does not need to know about each distribution to cross-check with the warehouse. They only need to know the sum. So basically, we sum up the entitlement on all the records in this auditing period, and we use a homomorphic commitment scheme to compute a commitment on the sum. The distribution station sends the aggregated data together with the records containing the signatures for the auditor to check whether the signatures are correct, the tags are unique, and the sum actually checks out. So why our design provides auditability? It is because in the threat model of auditability, the distribution station is malicious. And the distribution station does not control the signing key inside the card, so it cannot create a valid signature. It cannot open the commitment to another entitlement either. And hence, the misbehavior of the distribution station will be caught at auditing. So to conclude, in a year-long collaboration with the ICRC, we propose a digital design tailored to their aid distribution scenario. And we provide 2 solutions. We instantiate our design into 2 solutions with smart cards and smartphones as digital tokens for different threat models. We also provide formal proofs for the security and privacy properties we have mentioned in this talk. We also show that using the empirical evaluation, we also show that with medium-sized distribution, our 2 instantiations can finish within a few seconds, which is no longer than the physical interaction that has to happen at the station. And with that, I conclude my talk. If you would like to know more details, please feel free to check out our paper, and I'm happy to answer questions. Thank you.